The last thing we reviewed together in the previous video was factorizing a vector of numbers. Here, just to demonstrate the point better to you, here as you can see, I have put a vector of strings. As you can see, they are not numbers. We have AA, AB, AC, and AA and AB. Okay, the size of the vector is 5. But with your human intelligence, you can figure it out easily that here we have only 3 different strings, AA, AB, and AC. AA is repeat of AA, and AB is repeat of AB. And so see what happens if we factorize FD. So what we expect is to see something that has 3 levels. I run it, and here you can see, here we have FD, size of 5, factorizing FD, we get 3 levels, as you can see. Why it is necessary this much factorizing? Because many times when we want to do classification models in data analytics, for example, if you want to classify something as very good, good, normal, bad, very bad, maybe the labels that you are doing, the vectors that you are doing has many repetition of these things, and you just want to know about the number of them. So quickly you can use this factor. This is another point about R that you don't find with other programming languages, and now you understand what it means that its complex tools are designed for statistics, are designed for data analytics, and it is a database programming language. We know R is a database programming language. Okay, so the first question is that how we are gonna save data in R. We are discussing this. We checked vectors, we did lists together, we did matrices together. There are also other things, for example, tables. And other things that may come to your mind is that, for example, you may say, I know Excel has a huge capacity to save and hold two-dimensional data. For example, I can make a matrix of a big size in Excel. Can we take advantage of that huge opportunity Excel offers us regarding saving and storing our data? Yes. That's the main reason you see this slide in front of you. It asks you why CSV files. One reason for why CSV files is the fact that I just explained to you. Spreadsheets are a huge help in data manipulation, data storage. But when we talk about the spreadsheets, the first option that comes to your mind is Excel. So why CSV? What is CSV? Maybe it is the first time that you are hearing about this. CSV are type of files that are exactly the same as Excel files in a structure and also in application. CSV stands for comma separated values, and between Excel files and CSV files are much easier to work with. It is best to save these files as CSV before reading them into R. So While R can read Excel files with each of these extensions, XLS and XLSX, these file types often cause problems. So when you have a set of data in Excel, very easily you can save it as a CSV file. You lose nothing in terms of data, and you are gonna have a CSV file that doesn't cause problem, and it is easier to work with. And it is the usual things also with the other programming languages like Java. Okay, my friends, here I have put for you a link for this 1 minute and 34-second video. So please check it. It is about R file. Since you cannot click it on this video, I'm gonna put this address also in the read first part of our class today. But just make sure you watch this 1 minute and 34-second video about CSV files. The main point of this activity is to show you how much it is easy to work with CSV files, because I know you already know how to work with Excel, and not advanced level of working with Excel, just handling your data in Excel. So make sure you are doing this activity one by one, and if you have any question, let me know. First, download this file, binary.csv, and through this link, I know you cannot click on this link on this video, so I'm gonna put this link for you in the read first part of our class today. Okay, it says that you get a binary.csv file. It says save it as an Excel file and see what changes happen. And let me tell you, for most of them, nothing would happen. No changes would happen. And it just want to tell you how much they are similar. So when you save this file as Excel file, or when you save this file as CSV file, no changes happens, but it wants you to do it yourself. For example, you go to the file menu of your binary.csv that is similar to Excel, and click on that. You go to save as, and you find over there an option of Excel file. Okay, it says save it as a text file. What changes happen? Open the text file by double clicking on it and check the results. Open the CSV file by double clicking on it and check the results. And finally, open the CSV file through edit. And for edit, you need to right click and right click and on the file and find it, and right click and put edit. And the things that in this activity is trying to exercise you for are the points that are discussed in the video to some degree. So make sure you are good with the video. That just 1 minute and 34 seconds video. When you check it, you are good for this, because when you open the CSV file through edit, the result would be different. Then save the file as a text file and check the results. Please go through them, and feel free to ask if you have any question. Your friends reach out to me sometimes, your friends, and maybe it is you. And they have noticed, you have noticed that how much quickly I reply your questions and to your request for Zoom meeting. So just feel comfortable about those things, and make sure you are completely caught up with this easy and helpful course. Now that we know we can use CSV files, in fact, spreadsheet structures, to create our databases or data sets in R, so it means when we are using R, we have our spreadsheet somewhere in our computer saved. So we just need to be able to read it through R. So when you want to read your data set through R, you need to know the address of that file. The point about the address of files in R is super simple. And just my friends, I have prepared this PowerPoint. It is based on Windows, okay? So if you are using Mac and if you encounter any problem, contact me and we are gonna work it out, okay? But just the same way you have handled all the things since you are using Mac, you just go and Google it and quickly, very helpful points pops up that you can use them. There are not that much differences, but for example, the way you can find the addresses in Windows is different from the way you can find the addresses in Mac. For example, here it says a typical file address in R is written as follows, that must be in double quotation marks. So one point that we notice is that when you want to make an address in R, you need to put quotation mark and another things, instead of a single backslash, you must have double backslash. Sometimes when you copy and paste the address, it automatically returns it to the R accepted format. For example, the last version of RStudio does this. Okay, but even if it doesn't do this very easily, you can put it, you must put it in the quotation mark, but any backslash you see, you need to make it double. Let me show you, for example, how to do it on my computer. Here you see there is a binary file. Now the name is a little bit different, binary 4. Okay, I right click on this. I go to properties and as you can see here, it says location, C, users, Jasemi, desktop. So I'm gonna take this. It gives you the location of the file. And as I told you, it is for Windows. If you are using Mac, you should use Mac's specific steps to get the location of a file. Now I got the location of the file and I'm putting it here. So I paste it here, and as you can see, it is the location. It is the location, but it has two problems. It is the location of the file. It is not the full address of the file. So I need to add the address of the file. As you can see, I add this, and I need to put the name of the file that you just saw. So as you remember, it is binary 4.csv. Okay, and after that we need to put this in a quotation mark, double quotation mark, as you can see I'm doing, and make all the backslash symbols or signs or anything, all the backslashes, a double backslash, as you can see. Now it's a perfect address in R. Now when I give it to R, R quickly goes to this location, and in this location goes to this file and run it. There are still some other ways to do this. They are easier, like this, that file.choose, a command that helps you to avoid the difficulty of typing the address. When you put file.choose, everything will be handled by Windows. In the next session, I'm going to show you this with some examples in R, but now you know two ways of referring to the files on your computer, through entering direct address and also through file.choose that easier